Okay, welcome back. Okay, next we continue on the same. Right, you can see this right. Now you look at this diagram. This is Earth, right? So this is a satellite. So satellite will always orbit according to this circle. Okay, the speed must be fast enough, must have this orbital speed lah, must have the orbital speed so that it can maintain in this position. Okay, this can last a few years time when non-stop orbiting like that. Okay, understand? If let's say you see this diagram, if the speed a slower than the orbital speed, so what happens? It will drop. You see, it will come down. When the speed slower than this orbital speed, okay, then it will drop. Same thing goes with this. You see, this speed dB is also slower than the orbital speed, so it will drop. So it will fall down. Okay, so the scientists must do the calculation very accurately so that we must have a certain speed so that the satellite will continue to orbit, constantly follow this diagram. Understand? All right. That is the importance of studying physics. You must know how to calculate the speed. What is the speed so that the satellite will remain here. Okay? Understand now? Class. Okay, let's look at here. If the speed of the satellite is lower than the orbital speed means they use a formula to calculate one. This will cause the satellite to fall back to the Earth. Okay? For example, trajectory A and B lah. Then this one A and B, they are falling down. Okay? Right. Then this is because the centripetal force is smaller than the gravitational force. Okay, when you don't have enough speed, so this centripetal force is a force will always maintain this object in this orbit. When this force because the speed is small, right? So the centripetal force becomes smaller. So then the gravity becomes too strong. That's why you pull the satellite to come back. Understand? Okay, okay, next section is geostationary and non-geostationary satellite. Okay, what is this? Now you have two types of satellite. One is geostationary, the other one is non-geostationary. Okay, you just read here, I think you understand. Okay, the geostationary satellite is an Earth orbiting satellite, orbit the Earth one. Okay, it is a type of geosynchronous satellite. Okay, a satellite in geostationary orbit is known as geostationary satellite. Okay, it has an orbital period of 24 hours and 1 day. Okay, remember now. Orbital period means 1 day, 24 hours must make one complete circle. Okay, which means that it completes one revolution around the Earth at the same time as the Earth completes one rotation. You know why or not? Because when the Earth makes one rotation in 1 day, right? This satellite also will make one complete oscillation in 1 day. So this makes the satellite appear permanently in our sky because the satellite is here, right? Our Earth is here. So the Earth turning, so this one also turn. The same lah. The same lah. So both turning with the same time. So means if the satellite in Malaysia, right, on top of Malaysia sky, it will always remain in Malaysia sky lah. Because same, Earth make one turn in 24 hours. Same thing goes to the satellite. The satellite also make one turn in one day, right? So which means that complete one revolution around the Earth, same time as the Earth complete one rotation. Okay. Next, a geostationary orbit, known as geostationary Earth orbit, or geosynchronous equatorial orbit, or GEO. Okay, sometimes in the handphone, in the 4G, 5G, you can see this kind of term there, higher level only you can study that. Is a circular orbit located at the altitude 35786 kilometers above the surface of Earth. You see, this is a distance the satellite must be placed on top of the Earth. Okay, for all these geostationary satellite have to be a very big distance, quite far, above the surface of the Earth with zero inclination to the equatorial plane. Okay, mean like this. Okay, this is the Earth. This is an equatorial line. Okay, zero incline means you must be 90 degrees. Okay, okay, this is the eclipse. So this one must be 90 degrees horizontal. Okay, it's a must be like that, Geostationary orbit must be around here. That must be 90 degrees. Okay, zero inclination means cannot be inclined, must be horizontal. Okay, and for geosynchronous orbit, this one may or may not. This one not necessary. Must be like that. Okay. All right, next one. Can you understand? Okay. Number 4. Since a geostationary satellite has the same orbit period as Earth, I told you just now, same time, right? So it's also travel from west to east. Okay, west to east, like on Earth line. The direction in which Earth rotates on its axis is therefore appear to hover at a single point. It always up in Malaysia sky. It will always stay there. In the sky, when observed from a given point on the ground, the satellite is geosynchronous. Okay, orbit has the same orbital period, which is 24 hours or 1 day, as that of the satellite in geostationary orbit. You can understand that? Okay, next. The only difference between geosynchronous satellite and geostationary satellite is that the geosynchronous satellite may or may not be following an inclined orbit. Okay, as I showed you just now, the diagram. Okay, while a geostationary satellite must follow non-inclined orbit. Understand? Okay, now we look at the diagram again. Now it's here. And then for geostationary satellite, if I follow here, this position, okay, is a must. Whereas for geosynchronous orbit, it can follow a little bit inclined, okay, follow this position, not necessarily at this equatorial, may or may not, okay, have to follow here, this position, okay. All right, next. Okay. In other words, a geostationary satellite always remains exactly above the Earth equator, we just now. Whereas number 7, geosynchronous satellites are typically used for various purposes, such as communicating back and forth with spacecraft, okay, like Hubble Space Telescope and shuttles, all these voice communication or internet, broadcasting cable TV and radio signal, as well as weather forecasting. Okay, see, most of these are functionable ones. Actually, they are follow geosynchronous satellite. I mean, they are in certain inclination angle, not exactly on top of the equatorial. Understand? Okay, number 8. Geostationary satellite can give detailed terrestrial This terrestrial means a universe in the sky, and the weather-related information about the geographical region, making them an ideal choice to predict climate trends in the region. In other words, means this geosynchronous satellite, the function is less now, okay, compared to geosynchronous satellite, more function. Here you can see here more function, okay. Whether this geostationary satellite only related to weather information to predict the climate trends in that region. Okay, and now we look at a few examples. These are the example of communication satellite launched by Malaysia, our country. Okay, yeah. Do you know all this or not? The first one is Measat 1 for communication. Measat 2 also 10 year also for communication. Okay, actually this Measat 1, Measat 2, all these belong to Maxis one, you know. Then we have Geosynchronous 2000 for Earth imaging, taking the pictures of Earth. Okay. Then we have Measat 3, 2006, and so on. And 2009 is the one Razak site. Okay, this is for Earth remote sensing. This is very important. Okay. Okay. Satellite, they are not in geostationary orbits, are known as non-geostationary satellite. Okay. Not in geostationary orbit means near the horizontal line are all considered non-geostationary satellite. Okay, all right, next. Okay, non-geostationary satellite orbit. Satellite almost always orbit closer to the Earth. This one is important. This type of satellite orbit closer to the Earth means faster compared to geostationary. This one is further. Okay, so mean NGSO satellite orbit with varying velocity depending on the orbit height. Okay, for example, you can see a few here. NGSO is non-geostationary. This is geostationary. You can see the difference, the height. Then you can see the height and the period. Okay, this one I think it's closer to the Earth, right? And then go faster. This one is slightly further from the Earth, then it takes longer time, right? And this one very, very far. Then we can know the period. And then this geostationary Earth orbit, approximately this value, then it's 24 hours. Okay, right. Okay, number 14 here. The average lifespan of LEO satellite is approximately 5 years. 5 years only now. But the average lifespan of geostationary satellite is approximately 8 years. This is longer, 8 years. Okay, so we take a break first. Okay, let's continue. Right, next one is escape velocity. Okay, what is escape velocity? Okay, we know that our Earth is always having this gravitational force pulling all the object towards the center, right? So when you want, for example, a rocket, you want to fly to the space, meaning you have to escape from the Earth, Okay? So you must have a certain speed. If your speed is too low, you can't escape. So you go up and you come back, right? So now let's say this rocket needs to escape from Earth, escape from here, go into the space to the moon, to other planets, right? So you must achieve a certain speed. So this speed also needs to be accurately calculated, right? So we call it escape velocity. Okay, right? First, the escape velocity is a minimum, minimum velocity of an object must have in order to overcome the gravitational pull of the Earth and escape into the outer space without ever falling back. Understand? Okay, okay. Let's say you want to run away from the Earth, right? You also must have a certain speed. Okay, all right. This is a rocket, of course. Okay, number two, an object which has this velocity at the surface of the Earth okay, sorry, okay, let's come back. Okay, an object which has this velocity, the escape velocity, at the surface of Earth will totally escape the Earth's gravitational field, ignoring the losses due to the atmosphere, okay, because of friction. Number 13, number 3. The escape velocity from Earth is about this speed. You must have this speed, then you can escape from the Earth. 11.2 kilometer per second, very fast and all. Okay, kilometer per second. Okay. Uh, this velocity is not simply given, it's accurately calculated by the scientists. Okay. Right, number 4. The escape velocity will be achieved when minimum kinetic energy supplied to the object from the rocket engine, kinetic energy has already overcome the gravitational potential energy. Okay, kinetic energy push you up, but this gravitational potential energy will pull you back, right? So the kinetic energy must overcome the gravitational potential, then we can escape. Understand now? Alright, next one is a formula. Yeah, here. Okay, gravitational potential energy of a body with a mass m on the surface is given by this formula. Actually, this is a formula for this gravitational force between two objects, right? We have this formula, right? But we put negative for potential energy because it's opposite. If the kinetic is going up, the potential is coming down, so that's why it becomes negative. Okay, negative. Okay. And this kinetic energy formula is still the same, half mv squared, you learn this formula, right? And now, this one must add up, okay? Must equal to 0. 1 because opposite direction, when you add it up, so it becomes 0, okay? Okay, can you understand or not? What we say this, the principle of conservation of energy still apply here, okay? The gravitational potential energy and the kinetic energy minimum, we say minimum, when you total up, it must be 0 because initially the energy is 0 before you start the engine. So when total energy is 0, it will always remains 0. So we apply this principle of conservation of energy formula. Okay, so we put this equal 0. Okay, when you total up, then we solve this equation, we get this famous formula. This is a formula to calculate escape velocity. Okay, square of 2gm over r. Okay, g is a constant of gravitational constant. M is mass of the Earth. Okay, mass of the Earth. When you want to escape from the Earth, is a mass of the Earth, and r is a distance from center of Earth. Okay, all right. Example. Given the mass of Earth with this value, universal gravitational constant G this value, and the Earth's radius is calculate the escape velocity of body from the surface. And from the surface of the Earth, you want to escape, so you calculate the velocity lah. Okay, to the G mass of the Earth divided by the distance which is the radius of the Earth. So you get this value. Okay. Is near to 11.2 kilometers per second. And you must have minimum this speed in order to escape from the Earth. Okay, understand? Okay, next. Number 6 here. Earth's atmosphere is a thin layers of air surrounding our planet. Okay, we have air surrounding us, right? How does Earth hold on to these thin layers of atmosphere? Have you ever wondered why this layer of air gets you never run away? You always maintain there. Now this is the answer. The answer is the force of gravity. Okay, the same force that keeps us on Earth is because of the force of the gravity maintaining, keep pulling the gases so that they stay near us. Okay, understand? Okay. The atmosphere make up of air particles, you read yourself. Okay. This one I think also important here. Okay, next. Okay, number 8. Aeroplane can never escape from the Earth. Aeroplanes, not like our MH370, Okay, because air is too thin above the altitude to hold the plane up. Okay, the air is too thin to hold them up. And the speed of the aeroplane, the main reason is because the speed of the aeroplane can never reach the escape velocity. Okay, the speed of the aeroplane never reach the escape velocity. Cannot get 11.2 kilometers per second. No. Okay, so these are the two reasons. The air is too thin above the altitude to hold the plane up. Okay, because aeroplane need the layer of air, right? Then we can fly. So because this layer of atmosphere is not thick enough, so that the aeroplane can fly away enough distance to achieve certain speed. Okay, and now solving problem involving escape velocity of rocket from the surface of Earth, Moon, Mars, and the Sun. Okay, all these are simple. Okay, this one you have a look at the table. This one you don't need to memorize, because first roughly you know this one can already. Okay, you look at Earth. You want to escape from the Earth, right? This one is speed, minimum speed. Okay. You want to escape from Venus. This is the minimum speed. Okay. You notice that this one is it. The sun. The sun, you want to escape from the sun, you must have this speed. This speed, I think, is impossible to achieve one. Okay. Yeah, okay. You spend some time to look at the table. Right, next. Okay, next one is here. The formula of gravitational acceleration of the surface of planet given by this, right? Gravity formula, right? Okay. And crossover, so the Gi equal to Gm, right? Therefore, the escape velocity on surface is given by this formula. Okay. 2Gm, just now we learned this formula, escape velocity formula, right? 2Gm over R. Okay. The formula for gravitational acceleration and escape velocity can be combined. Okay. How to combine? Okay, we put this formula V equal to this, right? Because Gm is equal to Gr squared, right? Okay, so we put this Gr squared to substitute Gm, so we get this one. Okay, understand that? And then finally we get this. So this is another formula to find escape velocity. So escape velocity got two formulas. First one is here, second one is here. Okay. Therefore, escape velocity from surface of planet can be calculated from the values of gravitational acceleration of this formula and the radius of the planet. Okay. You either use this or use this. Okay. Let's answer question 1, 2, 3. Look at the questions. What are the man-made satellite and natural satellite? Give one example. Okay. What are man-made and what are natural satellite? Okay, see the answer. The answer I already prepared here. First week answer now. Man-made satellites are made by man, okay, which is launched by rocket. You must have a rocket to bring them up into the space and orbit around the Earth for certain purposes. One example, International Space Station (ISS), or another one is NASAC 1, NASAC 2, 3, and so on, right? Whereas natural satellite, any object in the space orbiting the larger planet. For example, the moon. Moon is natural satellite. Moon is orbiting around the Earth, right? Okay, understand? Okay, question number 2. Two is calculation now. A satellite moves with a velocity v in its own orbit. The height of the satellite from the Earth is this. What is the orbital velocity? Remember the formula or not? What is the formula to find the orbital velocity v? No, it's on this side, okay? So we have G here, we have M here, we have R, substitute in the formula. Okay, and then we get this answer. G value, mass of the Earth, and R, the radius. Okay, why need to plus 500 then? Why need to plus 500? Okay, let's look at the question. Because the question says the satellite is 500 kilometers away from the surface. So total distance must be the radius of Earth plus the 500. Okay, that's why we get this one. Okay. So this is our calculation. Now you have to be very careful. Use the calculator, type carefully, look at this answer. So this is the escape velocity of that satellite. Okay, okay, last question. The escape velocity of planet Y is this. Okay. Calculate the escape velocity of the planet X, another planet. If the mass of the X is 1.41 times the mass of planet Y, means X is heavier. Okay, the mass is bigger compared to Y. Y actual velocity is this, whereas X, the mass is 1.41 times bigger. Okay, and the radius is 0.919 times the radius of Y. Okay, these are all these values. Okay, now we look at the answer. Okay, with this formula, escape velocity for Y, this formula is given 17919 for Y equal to this. Okay, so this equation 1, because of this value we don't know. Okay, whereas escape velocity for X, 2g, the mass is 1.41 mass of this line, so 1.41 m. So this is m, this is 1.41 m, and this is r, so this one is 0.901 r. Now it is given in the question. Okay, then I divide 2 divided by 1. This equation divided by this. Okay, this one divided by this. Here you see yourself and I can understand more. This one divide by this, you get this. Here, this one divide by this. Divide, they change to multiply, then it's about it. Right now, cancel 2G, cancel the M, cancel the R. So finally, you get this answer. Okay, 2218 meter per second. Okay, understand? Okay, it seems like our lesson are almost finished now. Chapter 3. Okay, let's go through here in chapter 3. What you all have learned here. This one is a summarize the summary of the whole chapter. Okay, let's go through slowly now. Okay, there are three subtopics here now. First one is Newton's law of universal gravitation. The second one is Kepler's law. Kepler's law, and the last one is we learned today, man-made satellite, right? Okay, under this Newton's law of gravitation, right? Okay, we have learned this gravitational force. This formula are very important, right? Then also we have learned this formula, gravitational acceleration formula, right? Okay, this one first formula. This one is the second formula. Then also from this formula, you can learn how to solve the problem of two objects at rest, the body above the surface, and so on. When you learn this formula, you can find the gravitational acceleration, right? Determine the mass. Use this formula to find the mass and velocity. And the last one is the importance of knowing the gravitational acceleration so that you can calculate the centripetal force of the satellite and planetary motion system by using this formula. Right? Okay, this one is a formula for centripetal force formula. You know what is centripetal force or not? Probably remember or not? It's a force to maintain the orbiting object. Okay, the object will orbit in a constant circle, right? You must have this force, centripetal force. Okay. Right, next is under Kepler's law. You learn three law, right? First one, second one, third. Okay, first law is orbit. Okay, orbit, meaning that object is orbiting the sun in the ellipse shape, okay. First law. Second law, okay. Second law is area. Talking about area. Okay, this area, take S1, same as this area. Okay, this area is the area covered by the planet in the same time. The time taken from here to here, and time taken from here to here, same. For the same time, it will cover the same area. This is very important. Same area at the same time interval. Yeah, this is Kepler's second law. And the third, Kepler's third law is say that is a relation between the periods and the orbit radius. Okay, we say scale of the period is directly proportional to the cube of the radius. Okay, okay, p square proportional to r cube, the formula now. And finally, this is what you have learned here today. Man-made satellite, you have satellite orbital velocity, this formula to find the orbital velocity. Then after that, we get another formula of this conceptualizing escape velocity. This is orbital velocity. This is escape velocity. So two velocities I learned together. And also we have learned geostationary and non-geostationary satellite that different. And once you know this formula, you can solve problem involving escape velocity or this. Okay. This one, Kepler's law, use the formula, this cube p square proportional to r cube. then you can solving problem using calculus technology. Okay, okay. So with that, we have finished our chapter 3. Okay, we have finished our chapter 3. Okay, now what I want to tell you is you must I have given you one set of questions, right? One set of this question. Okay, the whole set of this question you must do finish it about the whole set. Now you can answer the whole set of questions already. Understand? The whole set of this question please do undo this man-made satellite over you must do finish it okay. Okay, I will keep you all later to answer now. Okay, so please remember to answer all these questions. Okay, so I see you again. Bye bye. Take good care of yourself. Bye. Okay, before I stop, I want to tell you something. We have finished chapter 3, and then I have given you a set of questions of whole chapter, right? So please answer all the questions on that set of questions before, okay? Understand that? One day we'll upload all the answers, right? You can check your answer. If you have any question, you can understand one, you just WhatsApp me to ask me, okay? Right, bye bye. Take good care, everyone. Bye.